So today we will be doing lesson 4.2. So a lesson for 4.2 and or 4-2. And the title is linear systems. So for linear systems, one of the main focuses is simply graphing lines. Remember, the word line is in the word linear. So if you ever wonder what the word linear refers to, it's kind of a technical sounding word, but it just means line. And a linear equation is just some equation whereby when you get solutions and you plot all of those solutions on an xy axis or on a two-dimensional grid. Let's say each of these points represents some solution to some two-variable linear equation. Here's a whole bunch of solutions. In between these 2 points, you would have a whole bunch of solutions as well, right? And really, there's an infinite amount of solutions between these points. And you could really just fill in all of the space between those points, because all of the space between those points also represent solutions. Also represent solutions to your linear equation. And we often, not always, but we often, and it's good to, draw arrows at either end of this line. And what that communicates is that our solutions continue down and to the right, and our solutions continue up and to the left. So let's just do a quick made-up example here, just to warm up. So what I'm going to write here, let's give a different coefficient. Let's give 3x, negative 3x plus, let's say 6y equals 12. All right, so what our goal here is going to be is to graph this linear equation, or you could say relation. It would be perfectly fine to call this a linear relation as well. So you could call it a relation because it relates x and y. This equation relates these two variables, x and y. All right, so let's do that. Typically, how we're going to want to go about graphing an equation like this is first to solve for y. That's the easiest way to do it. So first, let's solve for y. To solve for y here, what we can do is we can get rid of what's crowding this y. One thing that's crowding this y is this coefficient of 6, but we won't worry about that yet. It'll actually be simpler. It'll be simpler first just to get rid of this term. So how do we get rid of the negative 3x? Well, we can add 3x. So we add 3x to the left-hand side. The purpose for doing that is to get rid of that term so that we just have y isolated on this side. But again, we have to do that to both sides. So we add 3x to the right-hand side as well. Let's rewrite our equation. So we have 6y equals 3x plus 12 now. Right? The 3x that we added is here, and then the regular 12 that we already had is here now. So now what we can do is we can divide both sides by 6, and when we do that, and the purpose for doing that is to have y completely alone, right? So here we have 6 times y. We want to get rid of that 6 so that the y is all alone on one side. And then this is a place where sometimes people get confused is, okay, I've divided this left-hand side by 6. Now, which of these two terms do I then divide by 6 on the right-hand side? And the answer is you divide the whole right-hand side by 6. So here we're dividing the whole right-hand side by 6. It is equivalent to say we are dividing both terms by 6. So either way you would like to look at it, both of those ways are equivalent. So here we have y equals 3 over 6 is really just 1/2 x plus 12 over 6 is 2. Another area that sometimes people might get confused is here we have 3 over 6, which I converted to 1/2, or you might say simplified to 1/2. And one alternative way that you can write this is you can say I have the 3, which the factor of 3 on top canceled with a factor of 3 on the bottom, so that denominator now only has a factor of 2 left, because 6 is really 2 times 3. And so we have 2 on our denominator and x on our numerator, so you could also write this as x over 2 rather than 1 over 2x. It's totally up to you. I prefer writing it this way because it's clear that 1 over 2 is the coefficient in front of our x term in this case. But if you write x over 2 instead, right, if you simplify 3x over 6 as just x over 2, that's perfectly legit. That's perfectly fine to do. All right, so this is now our equation. We've solved for y. So this is our simplified linear relation. We often like to solve for y like this because it's useful then to plug in values of x. And so let's do that. Let's plug in values of x. And when we do that, we're going to see what we get out. So I want to be able to track the values of x that I'm plugging in and the values of y that are produced from each one of those inputs, we'll call them, inputs into x. So to do that, I'm going to create a table of values here. We've talked about tables of values before. A table of values is just one way to represent, another way to represent a linear relation. Just gathering these solutions together, these corresponding values. Okay, so one thing that it is super easy to plug in first, right? What's a really easy value for x to plug in? Usually 0 is a really easy value to start with. So let's plug 0 in for x. If we plug 0 in for x, we're going to have y equals 1 over 2 times the value of x plus 2. The value of x that we're choosing is 0. 1 over 2 times 0 is 0. So we get y equals 2. So when x is 0, y is 2. Let's plug in another value. Typically, if your denominator is 2, you would want to, just so that the numbers work out nicely, you would want to plug in a value for x that has a factor of 2 in it. So we could plug in x equals 2 or x equals 4 or x equals 6. Let's plug in x equals 4 and see what we get. So if we plug in x equals 4, then we're going to have y equals 1 over 2 times x plus 2. What value of x have we plugged in? 4. Okay, so a half times 4 is really just 2. So a half times 4 is 2, and then we are adding 2 to that, so we get 4. Let me make sure that this is in view. We get y equals 4. So, in other words, when x is 4 for this particular relation, y is also 4. So when x is 4, y is also 4. And that is really all you need to do. So plug in values of x. So all you really need to do is try 2 values. You could try 3 values if you want, but to successfully graph a line, really all you need is to plug in 2 x values. That gives you 2 points, right? 2 corresponding x and y values, 2 ordered pairs. Step 3 is just to graph your solutions or points or whatever you want to call them. All right, so we have 2 points. We have 0 and 2. We have 4 and 4. So let's graph this line. Let's do this. Let's do these x and y axes in a different color. So this is our y axis, our horizontal axis. This is our our y-axis is our vertical axis. I misspoke there. Our y-axis is our vertical axis. Our x-axis is our horizontal axis. We need a smallest x value of 0 and a largest x value of 4. So I'll just draw out 1, 2, 3, 4 chunks on this line here. This will represent x equals 4. Our smallest y value is 2, and our largest y value is 4, so I'll need to go up to 4 for our y values as well. And now I can just, and this represents 4, and now I can just plot these points. So when x is 0, so I'm not to the right on my x-axis, I'm not to the left in my negative values, I'm right in the middle. So when x is 0, y is 2, or my vertical value is 1, 2. So there is my first point. What's my second point? And by the way, let's label that. This is the point 0 and 2. And when x is 4, y is 4. So let's plot that point as well. So when I have 4 on my horizontal axis, 1, 2, 3, 4 units to the right here, I also go up by 1, 2, 3, 4 on my vertical axis. And so this should be that corresponding point, 4 and 4. I have my 2 points. All I need to do is connect them. Ideally, you'll have like a ruler or something. I don't want to risk putting a ruler on this screen. I feel like something would glitch out or something. So I will just connect these 2 points into a seemingly straight line. I will draw arrows at the end of it. I'll draw arrows at the end. And those arrows tell the reader that this line continues up and to the right forever and down and to the left forever. And how you should view this line is that this line is the set of all points, all ordered pairs that would be solutions to this particular equation. So when we say something like graph y equals 1/2 x plus 2, this line is what we want. So this equation and this line both represent the same relation between the variables y and x. And in the next video, what we're going to do is we're going to look at a little bit more of a systematic way of looking at an equation in this form solved for y, and how we can look at specific pieces of this equation, namely these 2 pieces that I will highlight in red, how we can look at these 2 pieces of an equation, which we'll eventually call certain names, to graph a line without plugging in values at all. And I will see you in the next video.